Hello everybody. We have some questions here that are related to probability, and we have one on statistics. So they're all GCSE questions. So let's get started. The first question is the probability of heads when a biased coin is thrown is 0.6. The coin is thrown 500 times. Circle the expected number of tails. So it is a biased coin. So as you can see, because the probability of the heads is 0.6, so if it was unbiased coin, then you'd have a fair chance, so the probability of heads and tails would be equal. So it is not. The probability of head is more. Okay, so here what we have to do is we have to find the probability of the tails. That is equal to 1 minus 0.6, and because there are 500 times the coin is thrown, so we have to multiply it by 500, and when you do that you would get 200. So 200 is your answer. The next question is the mean mass of a squad of 19 hockey players is 82 kgs. A player of mass 93 kg joins the squad. Work out the mean mass of the squad now. So when they say mean, by definition, mean should mean is, or mean should mean, I was about to say, but mean is the 82 is the answer. So if you have x as the total mass, okay, of the players, so then if you divide that by 19 you should get 82. So the total mass of the players would be 82 times 19, 82 times 19, and that is equal to, okay, 1558. Okay, so now we have a player of mass 93 kg who has joined the squad, so your total mass would increase to 1558 plus 93, and we have to divide it by 20. So that would be the mean mass of the squad now, and when you do that your answer is 82.55 kg. Okay, so the next question, oh, this I have done it for you in a proper way, typed it all out nicely so it's easier to understand what I have done, the working. Okay, the next one is we have in a restaurant. Now there are 9 starter dishes, there are 15 main dishes, and there are 8 dessert dishes. So Janet is going to choose one of the following combinations for her meal, and we have to show that there are 1, 3, 3, 5 different ways to choose the meal. Okay, so these are the ways of choosing. So you have one starter dish. We have to consider each case separately. So if you have one starter dish and one main dish, how many ways can you choose it? So one starter dish can be chosen from 9 starter dishes. Okay, so we have 9 starter dish. We only need one. A is 1, and this is also one main dish. So it is in 9 ways. So we are going to multiply 9 times 15, because there are 15 ways in which you can choose 15 main dishes. So then we have a main dish and a dessert dish. So once again, the main dish can be chosen in 15 ways, the dessert dish can be chosen in 8 ways. Then we have a starter dish, main, and a dessert dish. So you can work it out very easily that this is going to be 9 times main dish is 15, times 8. So when you do the equals, you will get 9 times 15 is 135. 15 times 8 is 120. 9 times 15 times 8 should give me 1080. Now find out what are the total number of ways. So the total number of ways, that's what we have to do. Total is 135 plus 120 plus 1080. So when you do that, you will get 5, you will get 3, you will get 3, you will get 1. So that answers this question. I've done it in a neater way here, right? So the next question is telling me a box of chocolates, okay, contains 12 chocolates. There are 7 milk chocolates and 7 are milk chocolate and 5 are white. 2 chocolates are chosen at random without replacement. Now this is the point to be noted, without replacement. So when you take one chocolate out of the box for the first pick, when you do the next pick, you have 1 chocolate less. So the total number of chocolates in the box will now be 11. And depending on whether you are choosing a milk, whether you're choosing or whether you have chosen a milk or a white, so the number of milk or white will come down by 1. So that, bearing that in mind, we are going to go and answer these questions. So the first one is given that the first chocolate is a milk chocolate. So if I write here A, so this one is not very clear. So A, if I write it as an A, so the first chocolate is a milk chocolate. So that is done. You know, this event is over. So the next one, what is the probability that the second chocolate is a milk chocolate? So the first chocolate has already been taken out. So and it is a milk chocolate. So how many milk chocolates are now left? There are 6 milk chocolates left out of how many? 11. And that is your answer. Okay, so that's A done. The next one is telling us, is asking us, not telling us, sorry. So let me just clean this thing. I've done it in a better way in a following slide, so it's very clear. The working is explained very clearly. So calculate the probability of at least 1 milk chocolate being chosen. So this thing about at least is that you have to start with not the probability of it not being a milk chocolate, and then 1 minus the probability of not. So if PA is the probability of milk chocolate, of no milk chocolate, or no milk chocolate, I should say white chocolate. If it's not a milk chocolate, it's a white chocolate. There's nothing else here. So it's either a milk or a white. So if it's not a milk chocolate, so probability of a white chocolate, 1 minus that probability will be at least. So that's the formula. Bearing that in mind, I think you already know the formulas by now. So what we have to do is at least one. So let us do it. So there are two picks. So there are twice you are picking. So we have to have the first pick, which is a white, and the second one, which is also a white, or both are no milk. Okay, so if I do this as a tree diagram, so the first pick is milk chocolate, the next is a white chocolate, and then we will have 2. So then we will continue with milk, white, and milk. So the first one, the probability of having a milk chocolate is 7 out of 12. the probability of having a white chocolate is 5 out of 12. That's the first time when you're picking it. And the next time when you pick, if it's a milk chocolate, the probability would be 6 out of 11. If it's a white chocolate, the probability would be 5 out of 11. It's similarly for the next one again. The next time you're doing a white, it is 4 out of 11. If it is a milk, it is going to be 5 out of 11. So what are the options? What will we pick from here? We will pick the options that are no milk. So no milk means I am going to pick a white, so that is at least one, and then I'm going to do 1 minus. So why are we doing it this way? That is the way it is done. Let us keep it to that, because otherwise we will get into this whole discussion. We can have another session for that, but this is specifically for this question. So the purpose of this question, to answer this question, we will restrict ourselves to explaining only the related part that's related to this question. So the question here, so what am I going to do? It is going to be 5 out of 12 multiplied by 4 out of 11, and this will be 1 minus, because we have taken this white and this white. Please bear in mind, we're taking these two cases, the two whites. We have excluded all the other cases because by definition they have said we want at least one. So at least one, it can be more than one, but at least one, right? So if for it to be at least one, we negate the we start with when it is not a white. So one, we remove the case where white is chosen, right? So that becomes 1 minus. So we do 3, so that is 5 out of 33. That it will give me 28 out of 33. So that is the answer, right? So I've done it in a better way. Oh, I haven't. No, we'll do the C first, and then I will move to the next slide. So I work out C. So what this is telling me is asking me, oh, we could have kept the tree diagram, but anyway, so we'll do it again. So then what this is saying, it is calculate the probability that 1 milk chocolate and 1 white chocolate are chosen in any order. So what are we going to do here? So the previous one, the one before that, previous question, I mean, the previous question, we were working out at least. Here it is not at least, it is in any order. So what that means is you can first pick a milk chocolate. So it is probability of an event, first event can be milk, probability of the next one can be, has to be white, and then again for the, it can be white, or the next one can be milk. So that's what we're going to work out with the tree diagram. Okay, so what I'm going to do is we will start with again the same things, right? So first I'm going to pick a milk chocolate. I'm going to pick a white chocolate next first, as we do with tree diagrams. So we have to make sure the probability of milk and the probability of white, when we add them up, we get 1. So the probability of milk is 7 out of 12, of it being a white is 5 out of 12, Okay, the next is it's going to be a white here and a milk here. So if it is a white here, the probability is going to be 5 out of 11, and if it is a milk, it is going to be 6 out of 11. Okay, because there's only, you have already taken out one milk, so there are 6 left out of 11. The next one is white, so once white is picked, the next one can be a milk or a white. So if the next one is a milk, it's going to be 5 out of 11 probability. If it's a white, it's going to be, no, sorry, yeah, if it's a milk, it is going to be 7. What am I doing? It is going to be 7 because I have 7 here, isn't it? It is going to be 7 out of 11. 7 out, sorry. So I'm going to do it again. 7 out of 11. And if it's going to be a white, okay, it is going to be, one white is out, it's going to be 4 out of 11. So how am I going to work it out? I am going to work it out adding them, adding up the two probabilities. So which two cases will I pick? I will pick these. So if I circle them, I will pick this part and I will pick this part. I will ignore the parts that are not needed. Okay, which is white and white, milk and milk. That is not needed. So what I'm going to do is, it is, your answer is 7, 12 plus 5, 11 times 5, 11, sorry, and I'm going to add this to 5, 12 times 7, 11. So I'm going to get 35 plus 35 times 132. That is 70 out of 132, and that equals 35 times 66. So because what you do is 2 times 35, 2 times 6, 12, and 6. So it's 35 out of 66. So that is your answer. So I worked it out in a version. So I've done A, okay, and then there is B. That's how I worked it out. So if you want to go back and look at this again, you can see how it is done in a neater way. So then we have the last one. Okay, so that concludes this little part on probability. Okay, if you have any questions, please do send me an email. Thank you for your time. Thank you. Bye.